So hi guys, I'm here to teach you about limits involving infinity asymptotes. By the way, my name is Liza Joy Borja. So first, I will give you some examples of my topic. So example number 1, the given is limit of 3x plus 5 over x minus 4, which is x approaches to infinity. So notice that as x gets large, the top gets large and the bottom gets large. So we can't immediately tell what the behavior of the function is as s gets large. We can think of this as a competition between the numerator and the denominator. Both are getting larger and larger, and the question is, does one of them outstrip the other, or do both of numerator and denominator stays even as they get larger? In this order, to figure this out, we need to use the following technique. First, divide the numerator and denominator by the highest power of x in the denominator. So here we will divide the top and bottom by x. So limit of 3x plus 5 over x all over x minus 4 over x, which is x is approaches to infinite. So we can now cancel the x in the numerator and x in the denominator. So here is the answer. Limit of 3 plus 5 over x all over 1 minus 4 over x, which is x approaches to infinity. Now we can evaluate the limit of the top and the limit of the bottom. So here, limit of 3 plus 5 over x all over 1 minus 4 over x, which is x approaches to infinity, equals limit of 3 plus 5 over x, which is x approaches to infinity, all over limit of 1 minus 4 over x, x approaches to infinity. So terms with x in the denominator are now going to 0. So here is the answer. 3 plus 0 over 1 minus 0 is equal to 3. So notice that now we can conclude that the numerator and denominator stayed about even as they grew larger. This is because the highest power of x in the numerator is the same as the highest power in the denominator. Notice that this also means that the function f of x equals 3x plus 5 over x minus 4 has a horizontal asymptotes of y equals to 3. So now I will give you my second example. So second example is evaluate the following limit. The given is limit of t squared plus 2 over t cubed plus 2 minus 1, which is t approaches to negative infinite. Notice that the limit of the top is infinite and the limit of the bottom is also infinite. So we must divide the numerator and denominator by the highest power of t in the denominator, which in this case is t cubed. So here is the solution. Is limit of 2 cubed plus 2 over 3 wrong. Limit of 2 squared plus 2 over t cubed over t cubed plus t squared minus 1 over t cubed. So the answer is limit is equals to limit over limit of 1 over t plus 2 over t cubed all over 1 plus 1 plus 1 over t minus 1 over t cubed. So, just simplify. So, with terms of t will be all going to 0 because the limit approaches to infinity. So, equals to 0 plus 0 over 1 plus 0 minus 0. So, the answer is 0. Since the limit is 0, we can conclude that the denominator outstrips the numerator. This is because the highest power of the t in the numerator is smaller than the highest power of t in the denominator. Notice that this means that the function f of t equals t squared plus 2 over t cubed plus 2 minus 1 has a horizontal asymptote of y equals 0. So that's all. Thank you for watching, everyone, my topic. Bye.